I wanted to take a few minutes to go over some object-oriented programming concepts. And while we're doing it, I am going to talk a little bit about UML, the Unified Modeling Language. If you remember in database, we constructed entity relationship diagrams. And in a lot of ways, UML for object-oriented programming is what ERDs do for database design. So we have classes. So you can see in relationships between classes, much like an entity would be in database. So this is a customer class. We got the name of the class up here. Underneath, we have the class's fields or properties. And then down here, we have the class's methods. Okay. So we can see that there's a relationship here, or in words of UML, it's called an association. One customer could have many orders in this design for this programming system that we're making for a restaurant, apparently. Then over here we have an order, and we can see it has some properties like order number or date, or if it's Java, they could be fields. Remember, the nomenclature changes slightly between languages. However, the nice part about UML is it's more of a concept. So we turn it into whatever we need it to be for the language that we're using. Okay. We also have a confirm method and a close method for the order. And then down here we have something called a normal order, and you can see it has the same properties as a regular order, but we've actually added a dispatch method. Okay? So this normal order is inherited from the regular order. So it uses all the code of the order, but then we have a dispatch method down here in addition. So this is a very general order. This is a more specific kind of order. And down here, we have even more specific. So you can see as we move down the inheritance, okay, so we're inheriting, one class inherits from the class above it. We're getting more specialized as we go down. This has even more methods, but also includes the methods that were part of order. Okay. We could have also had other properties that were included. I didn't do it on this diagram though. So as we move down inheritance, we get specialization. As we get up, we get more general. Okay. These are very specific types of orders down here. This is more of a general type of order down here. Each of them is classes that inherit from the other class. Okay, and we've seen diagrams similar to this already, especially in Greenfoot. We use them quite often. We use these inheritance diagram. A normal order is a order. Remember, that is a language that we talked about way back in inheritance in Java. A special order is a normal order. A special order is a specialized type of order. So it is a language, right? We also use some of these terms over here. Order is the superclass for normal order. Normal order is the subclass of order. Okay. Or we could use parent-child. Order is the parent of a normal order. Normal order is the child of an order. So these terms we can talk about them in terms of superclass and subclass. We can talk about them in terms of parent and child. We can talk about the idea of specialization or generalization as we move up and down this inheritance ladder. Okay, so UML is not hard to understand. If somebody said, hey, go out and write this normal order class, you could probably do it. Without a problem. You may have to understand what they want for confirm and close, but you could write the skeleton of the class just based on looking at this diagram. Okay. Now there's a couple other concepts I want to talk about that we may have talked about in our Java CCP class, but we may not have talked about it a lot in our regular Java programming last fall. Okay, and that is these two ideas, aggregation and composition. We probably talked about composition if we talked about anything, and that's the idea that a class can actually hold other classes. Okay, so if we have a class called person, a person could have some legs, right? And some hands and some heads. Okay, and if we created each of these as a class, a head might have some properties and a head might have some methods. Maybe we're making a robot, right? So we have a head structure, we have a hand structure that has properties and methods, and we have a leg structure, also an object. But the person has 3 fields, one for its head, or maybe one for its head, 2 for its hands, and 2 for its legs. Okay, so aggregation is much the same. A car is made up of an engine object and a wheel object and maybe a frame object and some other objects all make up a car. So what's the difference between aggregation and composition? It's kind of the same concept, right? Composition is usually for things that really can't exist on their own. We don't have a head that isn't connected to a person, right? The hand is connected to a person. So we would only create those things in the context of a person, where an engine could be, it could stand by itself, and it could be used in a car or a train or an airplane. So these things can be separated. So we could build these external classes and then put them together as an assembly to make a car. That's aggregation. These things can't really exist without the whole person. So even though it's the same thing, separate classes that are part of a bigger class, one of them is called composition. They can't be easily separated. One of them is called aggregation. They can exist on their own. So those are just some quick object-oriented terms that I wanted to make sure you understood in preparation for your exams.